In the interval 0 less than or equal to x less than or equal to 2 pi, the equation sine of 2 cos 2x plus 2 equals 0 has exactly 2, 3, 4, 6, or 8 solutions. Okay, so my first thought here is to first write out all the values that allow sine of theta to be equal to 0. And then, we will have several equations. There are clearly several values of theta which allow sine of theta equals 0. And then we want to set theta equal to 2 cosine of 2x plus 2 and solve for x. We will have to keep track of, the interval for x will be relevant, but only for the second part of this thing that I've outlined. In choosing a value of theta, well, we'll have to keep track of like different values of theta, different values of x, and so on. Okay, so let's write this out and then, just start working through with what my idea was. So the first part of this is pretty easy. Like sine theta equals 0 has, if you picture what the sinusoid function looks like, is equal to 0 at integer multiples of pi. And so what we'll need to do is I'll start for, I'll set this equal to 0 and solve for all possible values of x. Then I'll set it equal to pi and solve for all possible values of x. And set it equal to negative pi and solve for all possible values of x within the indicated interval. Eventually, though, there will be values of theta here, which this cannot be equal to because, this is bounded between 1 and negative 1. So, we cannot set this to any arbitrary real number and expect to have solutions. So let's start with theta equals 0. So cosine of 2x is equal to negative 1. This means 2x is equal to pi, right? And that's the only, and this means x is equal to pi over 2. So is there another value of x between, so cosine of x looks like that, where that bound is 2 pi. That there is pi. So cosine of 2x goes from 2 pi to 4 pi, like that. Well, hold on. No. That's not what I want to do. It goes twice as fast. So this becomes pi over 2. This becomes pi. And then there's another cycle of this. So why don't I instead redraw everything. If this is cosine of x, where this goes to 2 pi, I'm going to redraw the curve as going twice as fast. Okay, so this here is pi. This is pi over 2. This is 3 pi over 2. So I have x equals pi over 2 or x equals 3 pi over 2. And those are the two values between 0 and 2 pi that satisfy this equation for theta equals 0. So let's try now theta equal to pi. So I've got 2 cosine of 2x plus 2 is equal to pi. Okay, pi minus 2 over 2 is approximately 3.14, 1.14 over 2. So that's approximately, let's just call it 0.55. The exact number is not going to be relevant. Okay, so when theta is equal to pi, 0.55, if we look at this figure up here, there's clearly going to be 4 solutions to this. 1, 2, 3, 4. Okay, so this gives 4 more solutions. And if I set theta equal to 2 pi, remember I said I want to iterate through all of the integer multiples of pi. If I set theta equal to 2 pi, then I'm pretty sure there won't be a value of x that works here. So this would turn into 2 pi minus 2. 2 pi minus 2 is about 4. And so 2 pi minus 2 over 2 is about 2. And so that's a line up here, and there's no solutions. So let's look at when theta is equal to negative pi. This might also not have any solutions. Okay, so what is this number? This is approximately negative 5. Negative 5 divided by 2 is 2.5. So that's a line down here. So the only value of theta, the only quantity we can put here such that there is a value of x that works is when this thing itself is equal to 0. Oh, sorry, and I forgot about this one, and pi. Sorry. So these two solutions work, and whatever the value of x happens to be corresponding to this one, there's 4 more solutions. So the answer should be 6, which is option D. Yeah. Pretty confident in this one. Not much more to say, really just breaking it down. You know, if you're really practicing this kind of stuff, I think you would probably get this one a lot more quickly. I really didn't have to work out the precise values here. I could have just instantly known that there were only 2 values that worked. Yeah, but this sort of double trig solution thing, I think worked out pretty nicely. And the key to understanding what the limit on the solutions is that a lot of the solutions to this will not correspond to solutions to the thing inside because, you know, it's out of the range. If I have much more to say about this one, I'll put it down in the description. Thanks for watching.